Dear students, good morning to one and all. So as per syllabus, the name of the subject fluid mechanics and machinery. So as per syllabus, the unit 1 topic is the fluid properties and flow characteristics. So this class we are going to discuss what is mean by fluid, what are the difference between fluid and solids, what are the properties of fluids. So all those things we are going to discuss. So first and foremost, everyone we want to know what is mean by fluid or definition of fluid. Fluid is a substance or liquid which is capable of flowing. So this is a basic fundamental definition of fluid. A fluid is a substance or liquid which is capable of flowing. It has no own shape but conforms to the shape of containing vessels. A fluid is a substance that continuously deforms under an applied shear force. So this is a basic fundamental definition of fluid. So the fluid is a substance which is capable of flowing. So for example, liquids are like water, milk, air, streams. Okay, this is a basic fundamental definition of fluid. Matter exists in two stages, solids and fluids. Fluid state is commonly divided into the liquids and gaseous states. So what is the basic difference between fluid and solids? A solid is generally one shape but change in volume under pure compressive load. It resists to change in shape without a change in volume under the application of tangential forces. The spacing and latitude of motion of molecules are very small in solids, large in a liquid and extremely large in gas. The intermolecular bonds are very strong in solids, weak in liquids and very weak in gases. Solids are very compact and rigid. Solid materials are steel, wood, plastics, etc. So these are the picture. This picture shows the difference between gases, solids and liquids. So here particular properties. So how to differ? That is a solid differ and gases. There are the three phases are there. The solid phase, the spacing is close, energy low, and the motion vibrational. The volume is a definite volume. Shape is also definite. Whereas liquid, close spacing, moderate energy, rotational motions and definite volume as well as indefinite shapes. Whereas gas, far apart, high energy, translational motions, indefinite volume and indefinite shape. These are the particle properties of gases, solids and liquids. So here the rigids and fixed, there is a shape and fixed volume of, there is a cannot be crushed. Here there is a not rigid, not fixed shape and a fixed volume. Here liquids, whereas gas not rigid, no fixed shape, no fixed volumes. So there is a difference between solid, liquid and gases. So as per as syllabus, this fluid mechanics. So the fluid mechanics, what is the definition? So fluid mechanics is the branch of science which deals with the behavior of fluids. Behavior of fluids like liquids or gases at rest as well as in motion. So this is a basic fundamental definition of fluid mechanics. Fluid mechanics is that branch of science which deals with the behavior of fluids. For example, liquid or gases at rest as well as in motion. So the branch of science deals with the static, kinematic and dynamic aspects of fluids. So this is a basic definition of fluid mechanics. The study of fluids at rest is called fluid statics. The study of fluids in motion where the pressure forces are not considered is called fluid kinematics. How the statics, fluid kinematics and fluid differ from fluid kinematics. The study of fluids at rest is called fluid statics, whereas the study of fluids in motion where the pressure forces are not considered is called fluid kinematics. So what are the units? There is a units and dimensions. So there are two types of units. There is a fundamental units. So another one is a derived units. We know very well the fundamental units are length LMT, that is a length, mass and time. So what are the derived units? So the derived units are expressed in terms of fundamental units. In this, these are area, velocity and pressure, etc. So these are the unit systems we are going to follow. There is a CGS units, FES units and MK units, SI units. Six basic units are there. There is a quantity. What are the quantity? Length, mass, time, temperature, current, luminosity. What is a SI unit for length? Meter. There is a time in second, mass in kilogram, temperature in Kelvin, then current is ampere. So what is the dimensions? Length for L, mass for M, there is a time for T, A for temperature, current for I, and luminosity is CD. Okay, so another two supplementary units. One is for measuring the plane angle is called radian, another for measuring solid angle for stadians. Okay, derived units, there is a quantity, volume, area, velocity, discharge, acceleration, force, torque, energy, work, power, pressure and density, dynamic viscosity, dynamic kinematic viscosity, surface tensions. Next one is what are the different types of fluids. So we are already discussed there is what is engine mechanism, what is the fluid. So another one is what are the different types of fluids are available. Basically the fluids are classified into five types. So the first and foremost is the ideal fluid, second one real fluid, Newtonian fluid, non-Newtonian fluid and ideal plastic fluids. These are the different types of fluids. So we will see one by one. So what is ideal fluid? First one is the ideal fluid, the fluid. So here the types of fluids, here the picture indicates what type of fluid. This is the ideal plastic fluids. This one is non-Newtonian fluids. This is a Newtonian fluid. This is the ideal fluids. So the picture shows the graph between shear stress versus velocity gradient. So we will see one by one. That is the ideal fluid, the fluid which incompressed and have no viscosity, falls in the category of ideal fluid. Here there is no viscosity. The fluid which has no viscosity, then this fluid is called as ideal fluid. So what is a real fluid? Real fluid, a fluid which has at least some viscosity is called real fluid. The fluid which consists of viscosity, then the fluid is called as a real fluid. There is no viscosity, there is ideal fluid. Newtonian fluid, there is in this it is the real fluid, obeys the Newton's law of viscosity. That is, shear stress is directly proportional to shear strain. So in Newtonian fluid, it must be obey the Newton's law of viscosity, and also shear stress is directly proportional to shear strain. It is known as Newtonian fluid. Non-Newtonian fluid, it does not obey. This type of flow does not obey the Newtonian law of viscosity, and also there is no shear stress does not directly proportional to shear strain. Then this fluid is called non-Newtonian fluid. For example, paint and toothpaste. Newtonian fluid, for example, water and kerosene. So final one, ideal plastic fluid. So the fluid having the value of shear stress more than the yield values and shear stress. It is proportional to shear strain. So then it is called ideal plastic fluid. Say a plastic fluid, a fluid having a value of shear stress more than the yield value and shear stress is proportional to the shear strain is known as ideal plastic fluids. So these are the basically five types of fluid available. Another one is what are the properties? We will move to the another one. What are the properties of fluids as per syllabus? So what is the definition of fluid mechanics? What is a fluid? So what are the fundamental units, derived units, and say basic fundamental units? Another one is what are the different types of fluids? So another one is the properties of fluids. So the basic fundamental unit, there is a density or mass density. It is defined as density and mass density. What is the definition of density or mass density? The density or mass of the fluid, it is defined as the ratio of mass of the fluid to its volume. So it is defined as it is the ratio of mass of the fluid to its volume. That is density. It is denoted by the letter rho equal to mass by volume. Therefore, rho equal to m by v. So by using this to estimate the density from the characteristic gas equation, PV equal to mRT. For water, 1000 kg per meter cube, mercury 13,600 kg per meter cube, air 1.23. Another second property, specific weight or weight density. It is defined as the ratio of weight of the fluid to the volume of the fluid. It is defined as the ratio of weight of the fluid and the volume of the fluid. The unit is Newton per meter cube. Third property, specific volume. The specific volume of a fluid defined as the volume of the fluid occupied by a unit mass or volume per unit mass of the fluid. Therefore, the specific volume equal to volume of the fluid divided by mass of the fluid. That is equal to 1 by rho. Rho equal to density of the fluid. The specific volume is 1 by reciprocal of density. Its unit is meter cube per kg. So another property is specific gravity or relative density. The specific gravity is defined as the ratio of the density of the fluid to the density of the standard fluid. The specific gravity is defined as the ratio of density of the fluid to the density of the standard fluid. So it is denoted by S. So specific gravity of the standard is mercury equal to 13.6. So these are the properties of fluids. So another one is the viscosity. It is very important property of fluids. There is first one is the viscosity is the property of fluid due to cohesion and interaction between molecules, which offers resistance to shear deformation. Different fluids deform at different rates under the same shear stress. Fluid with a high viscosity such as syrup deforms more slowly than fluid with a low viscosity such as water. Therefore, shear stress tau equal to mu by du by dy. Another one is a dynamic. There are two types of viscosity: dynamic viscosity. Another one is the kinematic viscosity. What is meant by dynamic viscosity? It is given as the shear stress required causing the unit rate of shear deformation. That is mu equal to tau by du by dy. It is denoted by mu. The unit is Newton seconds per meter square. So another one is the kinematic viscosity. It is defined as the ratio of dynamic viscosity to the mass density. It is denoted by mu. That is mu equal to mu by rho. Its unit is meter square by second.